Oh, you sons of guns, I knew it.
Alright, so it looks like we're going down this road again. I'm Mr. Earth Guy, geologist, scientist, and communicator, and today we're gonna debunk this idiot.
Look at the wood structure here. We know that this is wood. And then have a look at the side of this mountain.
Yeah, so what I'm seeing there is a cliffside with a bunch of fractures and joints, typical from sedimentary and igneous and metamorphic rocks. Just because two things kind of look similar, it's just a pareidolia effect, doesn't mean that they're the same thing.
I mean, look at this. Buddy literally goes to a side of a mountain and just starts peeling the wood away.
So one of the interesting things specifically about that clip, I have no reference or source as to what that is, but what usually happens with either metamorphic or igneous rocks when they basically get uplifted from the ground, they go through this process called onion skin weathering or onion peel weathering. When these rocks sort of rise due to tectonic activity, the reduction in pressure basically creates these fractures and joints, which can be rather radial, which is why you can just break them off by hand sometimes because it's just so easy to fracture.
Now, wood doesn't just rot, it can mineralize. Have you ever seen the petrified forest of Arizona?
A petrified tree is literally rock, that's all it is, but it's taken the shape of the structure in which it was formed, which in this case is a tree. Basically, if a tree dies and it is felled or it falls over and is buried rather quickly, and if there's some form of groundwater, which is usually silica rich in the area, what can happen is as this tree slowly starts to rot and decay, the groundwater silica will basically permineralize, come out of solution and fill all the voids, the cellular walls, all of the organic parts that once were get infilled by this siliceous material, creating a mold of the tree, an exact replica in some instances, which is what you see in this video. It's very fascinating, but key there is it only mineralizes from trees that once existed.
And I want you to ask yourself this: does this truly look like a mountain to you?
No, that looks fake, because that's fake.
Or does it look like a tree stump with a flat top? All of these huge mountains with flat tops used to be colossal trees.
Yeah, the mesas, the tabletop mountains, the buttes, they're all trees apparently. These massive rock structures which were created from tectonic uplift. The reason why they have flat surfaces is because they have been eroded around the sides. They look like they've risen up, and they kind of have. Usually tectonic uplift, so these plateaus rise up, and water itself erodes around, leaving these really high relief structures with very flat tops. If these were trees, we need to know how they stood up, because lignin, which is found in trees that gives it its structure and rigidity, basically caps out about 115, 120 meters, which are the redwoods that you find in America. We don't know of any other organic materials that can basically create trees that big and that tall.